Hi everyone, welcome to Weekly Tech. Today we are going to be talking about RAG. So RAG stands for Retrieval Augmented Generation. So let's see what we're going to cover today. First, we're going to talk about the prerequisites, which are the stuff that you need to know before talking about RAG. So we're going to cover what LLMs are, the training data, hallucinations, how to stop hallucinations, context windows, and embeddings. Next, we're going to go to the main topic. And in RAG, we have three stages mainly: pre-processing, retrieval, and generation. So let's go through each one of them. So first, we're going to talk about what LLMs are. LLMs are also called as large language models, and basically they understand and generate text. So the most simple version of an LLM is a question answering chatbot. We can ask LLM a question and it can answer it. So the way it does it is by utilizing training data. So LLMs are trained on vast amounts of data and they learn from that data, meaning they identify patterns and they learn language and English language from that data. So the data consists of a bunch of text and then this text is trained into the LLM. Now this text has information and the LLM can use the information within this text for its own answers. The thing is, the LLM will not preserve all of the information in the training data. So it can remember some common facts, but it cannot remember specific facts or rare facts. So when an LLM does not remember these specific facts, sometimes it just makes them up. So this is called hallucination, and the LLM hallucinates false information. Okay, so this is very common in specific domains. So if you're using it in specific domains like legal situations and medical situations, the hallucinations are extremely common. So, for example, we ask it a very specific question like how much did Apple earn in 2017? So, there's a specific number for this and it's not really referenced that much. So, the LLM may forget this because it may not be that much of an important information. So, it can give some random answer and that would be wrong. So, there are ways to mitigate these hallucinations. So, one main way to mitigate these hallucinations is to provide the LLM the relevant data to answer from. So, the relevant data can include a set of documents, so the LLM can answer from that. So, this data can be in the form of tables, so the LLM can query an SQL database. It can be in the form of plain text, like a bunch of documents, or it can be in form of structured text, like JSON. So one thing to keep in mind about is any LLM there's a thing called context window. So context window, also called context length, is the amount of information an LLM can handle. Now due to recent advancements, the context window of LLMs are increasing. However, even if the context window of LLMs are increasing, there are two drawbacks to this. One is that if you put a lot of context into an LLM, the price also will increase. So just because you can put a lot of documents into an LLM does not mean you have to. So this is why this is one of the drawbacks. The other drawback is even if you put all the documents into the LLM and you're okay with it, you know, ending up having a much higher cost, the LLM may not actually remember the information because it's just like a human. Okay, so if you read a book, I can ask you questions from it. So you may remember the main points about the book or maybe the starting of the book, but there's no way you'd remember the entirety of the book in such a short amount of time. So this is kind of what happens with LLMs too. So yeah, LLMs cannot remember all of the input, and there's a thing for this. So essentially, uh, LLMs, if there's a bunch of text, okay, they can remember the starting of the text and they can remember the ending of the text. But the middle, which is the where most of the information is, gets lost. So to prevent this, there's a method. We're gonna discuss about it. So before we discuss about RAG and how it solves this problem, we have to first learn about embeddings. Okay, so embeddings are vector versions of text. Now vectors are essentially a list of numbers. So you can think of these as arrays. Okay, so this is in a way that similar words will have similar arrays. So road will be similar to street because they represent similar things, and apple will be similar to fruit because apple is a fruit. Okay, so essentially we have text, and the text contains a bunch of words. Now we cannot directly feed this into a program because programs do not understand human language. So what we do is we vectorize this and convert it into a vector, a list of numbers. Okay. So what we can do with these vectors is that we can compare two vectors. So we can say we have a different piece of text, and we can generate another vector corresponding to this piece of text. So we know that these two pieces of text are similar only when the vector is also similar. So we can identify the relevance of a information to question. For example, this is the question, okay, and this is a possible answer. Now, if these two vectors are similar, then we know that the answer is probably highly related to the question. But say the question is something about a medical disease and the answer is relating to something about technology. So there's not much similarity, and so the vectors will also not be similar. I hope you understand this. So now we can move on to the main topic, which is retrieval augmented generation. So retrieval is basically when documents are retrieved, so they are gathered. So essentially, if we have a bunch of text, instead of giving all of the text to the LLM, we will only give the required information. So for example, we have a bunch of text about a country, and the question is how much is the population in that country. So instead of giving the entire documents, we can just give the population chunk. So let's see how this happens. So we have a list of documents. Okay. Now we cannot directly put these documents and vectorize them. So we need to separate them into small chunks. So chunks are part of a document. So you can set the chunk size on your own. The thing is, if you set the chunk size to be very large, then the LLM may not even be able to understand that large of a chunk, because say for example your LLM can only understand a couple thousand tokens. If the chunk is bigger than that, then you cannot put it into the LLM. Okay, so once we have these chunks, we store them in a vector DB. Basically we vectorize them. So a vector DB is essentially where we have text and we have a vector. So we understand that for this particular text, this is the vector. And so it's essentially a list of vectors and text. So then, given a query, so for example, there's a question, we will identify what pieces of text, what chunks are most relevant to that question. So then we retrieve them. So we put them into the LLM, and the LLM will generate the answer. So before moving on with RAG, we need to understand about pre-processing. So pre-processing is essentially processing the data before giving it to the LLM. So first thing is chunking. Okay, so there are main two parameters in chunking. First is the chunk size. So we have, for example, a document. Okay, so you can divide this document into chunks, and we can set how big the chunk size is. So maybe this is 1,000 words, this is 1,000 words, and this is 1,000 words. The next is overlap. So for example, we want some overlap to be there between two chunks. So for example, there's some information in between. Okay, so we do not want this information to get lost in either one of the chunk. So what we do is we give this information both to this chunk and to this chunk. So essentially there's going to be a bit of an overlap in between both of these chunks. And so the LLM will identify the proper context for the chunk. Next is vectorization, which I've already talked about, where we vectorize the chunks into a list of numbers so we can identify which chunks are most important. Next comes retrieval. So there are actually two steps to retrieval. So for example, we have a database. Okay. So this database has a bunch of vectors and text. So first, we compare the vectors and we'll get, for example, top 20. Okay. Then we'll give it to the larger model called a re-ranking model. So the difference between a retrieval model and a re-ranking model is that retrieval model is faster but it is less accurate. Re-ranking model on the other hand is slower but more accurate. So we cannot practically run re-ranking model on the entire set of data. So what we do is we first run the retrieval model, then we'll extract the top 20 most relevant information, and then we'll re-rank this. So out of this top 20, with the re-ranking model, we can select, for example, the top 5. So the difference between a retrieval model and a re-ranking model is that the retrieval model is a general model. It just converts text into vectors. So you can identify which text is similar to other text. But re-ranking model will identify the information and will check if the specific information is there within text. So for example, this document is about France and our question is also related to France. Okay. Now if you use a retrieval model only, then for every chunk there will be similarity because both question and the retrieval or the documents are both related to France. So there will always be similarity. But re-ranking model will identify that, for example, the question is what is the population of France? So it will identify exactly what chunks are relevant to the population and not just generally France. Okay. So I hope you understand this. So this is the final process. So we have a bunch of documents and we chunk those documents. Okay, then there will be a list of chunks. Then we embed the chunks and then there will be retrieval documents or see the set of documents along with their corresponding vectors. Okay, so then we'll receive a query. So this query is a question. Now for this query also we'll convert it into a vector so that we can compare it with the documents. Okay, so we'll compare the query vector to the document vectors. And from this, we can say that, okay, these documents are most similar to this query. And we'll select the top 20 documents. Then we'll re-rank the documents and we'll select a smaller set of documents. So I have chosen 3 in this case. And we'll give this to the LLM. So the LLM will use these documents and output. So there are still some limitations of RAG that have to be addressed. So first, RAG is not good for summarization or classification. Because summarization, you have to look at the entire document. Okay, so you have to look at this entire document and identify the key points. So RAG is only looking at a specific part of this document. Next, the quality of this RAG process is dependent on the quality mainly of the retriever and reanchor and also LLM. So what do I mean by this? For example, we have a document and it contains the relevant information, but the retriever and re-anchors are not able to, let's say, extract the information. Then this information will not even go into the LLM in the first place and the LLM will give a wrong answer. So because of this, the whole RAG process will get affected. And in some cases, instead of using vectors, we can use keyword search. So keyword search is a more traditional search algorithm. For example, this document contains words like France, politics, government, and Europe. Okay, so if our query also contains those words, then this document will be retrieved. So this is sometimes better than the traditional like or classic vector implementation. And actually, these algorithms are actually older, but they haven't really been used widely in the context of RAG. So BM25 is one notable algorithm. So you can use this algorithm in place of vector search. So I have some more resources. If you want to actually implement this in code, you can use some frameworks like LangChain and Llama Index. These are Python frameworks that you can use along with OpenAI. And you can use any LLM and text embedding model. So there's no need to use specifically OpenAI and ChatGPT. You can use various LLM providers and you can run your own models. You can run Llama 3 as well. Okay, and there are actually other types of RAG, and these are more advanced forms of RAG, and I highly recommend you look into these. There are comprehensive research papers that talk about these, mainly Graph RAG, which was developed by Microsoft. So yeah, thanks for watching. I hope this video is helpful for you. If you like this video, please like the video and subscribe to our channel so I can make more videos like this in the future. So please hit the subscribe button and the notification bell. Thank you.